Yeah, dear students, I am going to explain the topic probability. Yeah, good evening. Today I am going to explain the topic probability. This is the 19th first PU revision class. Maximum many topics I have covered. If you follow these topics, definitely you are able to get good score. Minimum 90%, minimum 90 marks you can score. I am expecting minimum 90 marks you can score easily. You follow these classes, definitely you can score minimum 90. I can give guarantee minimum 90. Practice these questions. Just whenever you want, you can pause the video, then you practice. Definitely you are able to get good score, no doubt in that. I can give guarantee for that. You can practice all these questions. Now the topic, in the previous session I have done permutation combinations. Now after doing that, you come to do this topic. So what is actually probability? Generally, probability, when they're talking probability, so suppose if you take A is an event, probability of A is equal to, they will write n of A by n of S. So when they're talking what is A here, see when I've taken A is an event, probability of A, they will write n of A by n of S. S is the sample space. Here where S is the sample space, A is the given event. Now the favorable events to A by total number of sample points gives P of A equal to n of A by n of S. It gives probability. P of A equal to n of A by n of S. Suppose sometimes they are talking about P of A dash. P of A dash means P of not A. When they are talking not A, automatically they give meaning 1 minus P of A. Remember these points. A complement is means not A. This meaning is not A. When they are talking not A, whenever they are using the word not A, so you can remove the probability 1 minus P of A. And also the probability value always lies between 0 and 1. Remember that. Whenever you are talking probability value, this value lies between 0 and 0 less than or equal to probability of any event. If suppose A is an event less than or equal to 1, always probability value lies between 0 and 1. Sometimes they may ask for one event, they may ask when do you get 0? For impossible event, the probability of impossible event empty set is equal to 0. The probability of sample space will be 1. Remember. So here empty set means impossible event. S means sure event. Probability of sure event is 1. Here when I have taken probability of S, S is called sure event. Sure event, definitely it occurs. Sure event is 1. Probability of empty set means 0 means here empty set is called impossible event. For example, you rolling a die, getting 7 is impossible event. So probability of rolling a die, probability of getting 7 will be 0. Probability of empty set will be 0. Probability of sample space will be 1. So here S is called sure event. Empty set means that will be 0. Empty probability of impossible event will be 0. Remember these are the points, the basic things I have given here. I hope you understood. I have explained only basic things here. Please follow that the class. Now here they are asking, just you remember these are the basic things. Probability of impossible event will be 0. Probability of sure event will be 1. So P of A dash will be 1 minus P of A, and P of A equal to n of A by n of S. See the first one, if 2 by 11 is the probability of an event A, the given P of A is given. P of A is given 2 by 11. They are asking what is the probability of the event not A. So P of not A means the meaning is they are asking not A. So whenever they are using the word not A, just you can observe here, not A means P of A dash, which is equal to 1 minus P of A. I can write 1 minus 2 by 11. It will come 11 minus 2 by 11. It comes 9 by 11. That's your answer, right? Simple, 9 by 11. Remember that 9 by 11. Simple one, right? Next, a coin is tossed and a die is thrown. Write the sample space. Sample space means the possible outcomes of the given experiment. The all outcomes of the given experiment is called sample space. A coin is tossed and a die is thrown. So what is the sample space? Generally we wrote sample space yes. So when a coin is tossed, head it comes. Die also thrown. H1, H2, H3, H4. So the possible by that H4, H5, H6. And so because coin is tossed, if head comes, then on the die these are the possible numbers. Then I can write now T1. You can consider like I have taken the now T1, T2, T3, T4, T5, T6 combination. This is T3, understood here. T3, T2, T3, T4, T5, T6. This is H. Head 4, head 5, right. Head 6. Like this total you will get 12. This is sample space H1, H2, H3, H4, H5, H6, comma T1, T2, T3, T4, T5, T6. These are the sample space for when a coin is tossed and a die is thrown. Write the sample space of the experiment. A coin is tossed repeatedly 3 times. A coin is tossed repeatedly 3 times means the sample space will be, you can see here, triple H. I can write HHT, HTH. See that HTH. I can write this one THH because triple H, 2H again next. I can write TTH, THT. Correct, THT. I have written this one. THT. I can write now. Correct, HTT and a triple T. Like this it comes. This is the total 8 of possible outcomes. This is sample space. A coin is repeatedly 3 times means your total 8 sample points will be there. Now, a letter is chosen at random from the word assassination. Find the probability that letter is a vowel. Total letters you can count here 3 and 4, 5, 6, 7, 8, 9, 10, 11. You can see the count here. Total letters in assassination we have 12 letters. So total 12 letters we have assassination, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 letters we have. Total 12. And vowels, how many we have total? Number of letters we have, 12 we have. This is the 12 letters we have. And vowels. See vowels, how many we have, you can check here. A is coming here 3 times and I is coming twice, 4, 5, O is here. Total we have 6 vowels. Total 12 letters for vowels are 6. Why? Because A is coming 3 times. I has come twice. And O has come 1 time. Total 6, right? It's clear. You can see A 3 times. I and O is here, vowels. Total we have 6. The favor vowels are 6, total letters are 12. The probability of getting vowel. They are asking what is the probability of getting vowel, they are asking. Probability of vowel equal to favorable cases 6, total letters 12, 6 by 12. Answer is 1 by 2. That is the probability of that letter is a vowel. Correct. You will get 1 by 12. Is clear that? Right. Next one. See, define a simple event. So, because just they given here, find the probability that is letter is a vowel. Vowels only 6. Total letters are 12. 6 by 12. That will be your answer. Simple answer. You can write that. To find the probability that is a vowel. That letter is vowel. Vowel we have only 6. 6 by 12. It comes 1 by 2. Correct. assassination is given, that I have written favorable. 12 letters are there, 6 letters we have. That is the probability of that. Next, define simple event. Don't consider here finding permutation combinations here. I'm not talking about permutation, only probability I'm talking. Define simple event. If an event E has only one sample point of a sample space, it is called a simple event. That is called a simple event. I hope you understood that. Simple event means if E is having only one sample point. For example, you can see here rolling a die. You can observe that when I have taken this one, if an event E has only one sample point of a sample space, it is called a simple event. Tossing a coin, getting head, that is simple event. Example I will tell you. Suppose S is H, this is simple event. Suppose S is equal to singleton T, simple event. Or S is equal to singleton 1, this is a simple event. If an event E has only one sample point of a sample space, it is called a simple event. Next one you can see that. Sixth one. If the experiment of a tossing a coin thrice, describe the event exactly one head appeared. They are talking exactly one head appeared. So they are talking only one head appeared. One head appeared means two toss will be there. Two tails will be there. HTT, THT, the possible, TTH. So these are the possible outcomes. They are talking exactly one head appeared. HTT, THT, TTH. These are the possible outcomes of yes. So a box contains one red, three identical white balls. Two balls are drawn at random in succession without replacement. A box contains one red, three identical white balls. Two balls are drawn at random in succession without replacement. They are not keeping back. Right sample space. So when you can see, observe here, you may get one red ball, one white ball, or you can get white red ball, or you will get both white balls. This is W. Both white balls. These are the possible sample space. So this is your answer, right? RW, W, or W, W. That's all. Look at these possible outcomes. Define sample space for a random experiment. What is the sample space means? I told you set of all possible outcomes. The set of all possible outcomes of a random experiment is called a sample space. You should learn this. The set of all possible outcomes of a random experiment is called a sample space. It is called a sample space. Simple event. Next one. A die is rolled. Describe the event A. A number less than 7 occurs. Check that. A die is rolled. Describe the event A. Number less than 7 occurs. Numbers less than 7 occurs means you can think is clear. A die is rolled. Describe the event a number less than 7 occurs. So what is the event number less than 7 means what is the number less than, what is A here? Number less than 7 means 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6 because less than 7 means all the numbers. Die is rolled. Then what are the possible outcomes? 1, 2, 3, 4, 5, 6 it comes. The possible outcomes are 1, 2, 3, 4, 5, 6. Correct. That's all simple. They're talking about event number less than 7 occurs. Is clear. This is a simple thing, right? If you have doubt, you can discuss with me. I can explain again and again. Please ask me. If you have doubt, please ask me. I can explain again and again. So, because just die rolled. Die is rolled. This is less than 7 occurs. This is the sample. Next one. Define sure event. The whole sample space is called sure event. Simple one. the whole sample space is called sure event. The whole sample space S is called sure event. All these are the all possible 1 mark questions. Define mutually exclusive events. What is the meaning of mutually exclusive? When they are talking mutually exclusive events, suppose if you take two events A and B, you will consider let A comma B two events. If A intersection B is equal to empty set, then I can say A and B are mutually exclusive events. Two events A and B are called mutual exclusive events if the occurrence of any of them excludes the occurrence of the other event. So they cannot occur simultaneously. Then we can say those two are mutual exclusive events. Another way, you can, in a simple way, let A comma B be two events. Let A comma B be two events. If you consider this, other way the people may confuse about the definition means you can let A comma B be two events. If A intersection B is equal to empty set, then A and B are called, whenever A intersection empty set, I can also, in this case I can write, then A and B are called mutually exclusive events. That was a simple definition you can write. A comma B two events. If A into empty set, then A and B are called mutual exclusive events. A comma B are called mutually exclusive events. I can say mutually exclusive events. Like this also I can write. Whenever intersection empty set, you can say mutually exclusive events. Mutual exclusive events I can say. So what is the mutual exhaustive events? When they are talking mutually exhaustive events, suppose if A same thing, A comma B two events, if A intersection B is equal to S, sample space S is equal to S. If A intersection B is equal to S, then A comma B are called mutually exhaustive events. A and B, A comma B are called mutually, I can say mutually exhaustive events. Mutually exhaustive. EXHAUS, exhaustive events. Remember, mutual exhaustive events. Whenever A intersection, not A intersection, here. A union B is equal to S. Remember, if A union B is equal to S, should be careful. Here A intersection with empty set, no common elements in that. Then we can say A comma B are called mutual exclusive events. Whenever A union B is equal to S, A comma B become mutually exhaustive events. Mutually exhaustive events. So these are the possible 1 mark questions they are asking. Next to 2 mark questions. Today I am going to explain 1 mark and 2 mark questions. Tomorrow morning I will explain remaining 2 mark and 3 marks. So tomorrow I can take it only half an hour. Tomorrow if I attend another 30 minutes, I can complete the probability. Today I am going to complete the probability another 15 minutes. It takes another 10-15 minutes. I am going to complete today's topic. Okay, now you can see that. Given P of A equal to 3 by 5, P of B equal to 1 by 5, find P of A or B. Given A and B are mutually exclusive. Since A and B are mutually exclusive, I can write here, since A comma B are mutually exclusive, because you observe here, since A comma B are mutually exclusive, are mutually exclusive means I can get probability of A intersection B is equal to 0. This will be 0. Probability of A intersection B equal to 0. Sir, why sir? Whenever mutual exclusive, we know that A intersection B is equal to empty set. Probability of empty set is 0. This result probability will be 0, correct? Now they are asking P of A or B. When they are asking P of A or B, whenever they are using P of A or B, the meaning P of A union B. When they are asking P of A union B, I can write P of A plus P of B minus P of A intersection B. Formula if I consider P of A intersection B. Substitute we know P of A 3 by 5. 3 by 5. I can sub 3 by 5 plus 1 by 5 minus 0. It will come 4 by 5. This is required answer. 4 by 5 is the required answer. That's a simple, right? 4 by 5 is the required answer. Now, see the 13th one. A comma B are two events. A comma B are two events. Such P of A equal 0.4 to P of B 0.48. Find P of A and B 0.16. Find P of not A. First one, P of not A means the meaning P of A dash. Do you remember P of A dash? P of A dash means 1 minus P of A. So what is P of A? 1 minus P of A is, we know that 0.42. You remove 0.42, it becomes 0.58. That will be your answer. Next, second one, P of not B. When they are asking P of not B, P of not B. When they are asking P of not B, similarly you can do like this, P of not B. So when they are talking P of not B, P of B dash 1 minus P of B. Now you can remove 1. What is P of B value? 0.48. Then it comes 0.52. 0.52. Third one, P of A and B. We know that they are asking P of A or B. P of A or B means P of A union B. P of A or B means P of A union B. If we take P of A or B, it will be P of A union B. So P of A, we know that P of A union B, P of A plus P of B. P of A, we can write this one, P of A plus P of B minus P of A intersection B. But we know P of A, P of A is given 0.42, 0.42 plus P of B 0.48 minus P of A intersection B is given 0.16. You simplify this value. 0.42, 0.48, you can simplify this value. We get, add those two values, 0.42 and 0. They will get 0. This one, if we add these two, 0.42, 0.48, 0.90, you substitute 0.16, right, 0.16. Alright, this is 90, right? Check here, 4. Right, 0.74 your answer. This is rougher, 0.74 it comes. Simple problem, but important problem. 14th one, a die is thrown. Write the sample space. Also find the probability of the event A. Number greater than or equal to 3 will appear. A die is thrown. Die is thrown means we know the sample space. What is sample space? Set of 1, 2, 3, 4, 5, 6. Again write set of 1, 2, 3, 4, 5, 6. Sample points will be n of s is equal to 6 we have. They are telling A is the event, number greater than or equal to 3 will appear. So you think about what is A here. When I have taken event A, if you take event A, 3 or more than 3. So you can write 3, 4, 5, 6. That means n of A is equal to favorable events 4. They are asking probability of A. P of A equal to n of A by n of S. Correct? You can write P of A equal to n of A by n of S. N of A by n of S. Then I can write here 4 by 6, it will be 2 by 3. That's all your answer, right? Simple thing. Next one. On the see here, on her vacations, Veena visits 4 cities A, B, C and D in random order. On her vacations, Veena visits 4 cities A, B, C and D in random order. What is the probability that she visits A before B? What is the probability that she visits A before B? Check that here, total 4. So what is the sample points? The number of sample points will be the given 4 places, right? A, B, what are the possible outcomes? What are the possible outcomes? Number of outcomes will be, so total 4 places I can write. Correct, 4 places. She can attend 4P4, right? 4 factorial, it will be 24, right? 4 into 3 into 2 into 1, it will be 24. Why? Because 4 places, any place she can visit, any order, n of s. Correct. Now 4P4 is 4 factorial, 4 places, any like this, all possible I have taken here. 4 into 3 into, other if you write 4 places, first place she can visit 4 ways, second place 3 ways, third place 2 ways, fourth place 1 way, total 24. That is the reason 4 into 3 into 2 into 1. I hope you understood this. These are sample points I have written. 4 into 3 into 2 into 1. Total 24 we got. Now the favorable events to the event A. Let it be, I will consider event A, E. They are saying here, what is the probability that she visits A before B? You can consider event E. She visits A before B. You take event E is equal to she visits A before B. She visits A before B. So what is the possible here? She visits before B. Now let's be careful here. The people may confuse here. Try to understand here what I'm going to explain here. So she visits before B means what are the possible outcomes are for A? Favorable to E. I'm going to find favorable to E. That is important here. If I'm going to favorable to here, suppose you can see here, if I fix A in the first place, you fix A, we have another 3 places we have. So this I can visit 3 ways. This is 2 ways, 1 way, right? So total we have 6 ways she can visit. When she visits first place is A, other places she can visit 6 ways. Why? Because they're saying she visits A before B. B should come any one of the place here. So I can fix 6 ways. I'm trying to find favorable event to E. She visits A before B, right? Then I can consider another option also. You can see here. Suppose what I'm thinking here, I can fix A here, and B I can fix these 2 places. Because whenever C and D, always she should visit A before B. I'm fixing here, she should visit before B. I hope you understood this, right? I have taken B here. B. I have taken B inside. In this place again here C or D, D or C, 2 ways. These 2 places we have, another 2 places we have, 2 gaps. You can write this way, you can do. How many ways you can do these 2 places? The possible you can think, a C or D, D or C, 2 ways we can do this. I can fill these 2 ways. This is 2 ways, this is 1 way. I can fill 2 into 1, 2 ways I can write. Correct? You will get 2 ways here. This is possible. Suppose another option I will tell you now. Check that. Suppose A is here and B is here. Here also she visits A before B. Again here 2 places where this is 2, this is 1 way. 2 into 1. Again it comes 2 ways. Another way. So these are the possible outcomes of E. The last option you can see. I'm talking about this one here. Suppose A is here and B is the last place. Again you can see two places, 2 into, this is one place, here 1, 2 into 1 it comes, right? This is two way, this is one way, it comes 2. Total if we count this one, total 12 it comes. That means favorable event to E, n of E is equal to 12. So sir, why you are doing this much? They are asking always she should visit A before B. She should visit A before B. So these are all possible outcomes. Total 12. Now the sum, then final answer I can write P of probability of E is equal to, final answer I can write probability of E. So probability of E is equal to n of E by n of S. So you will get 12 by 24. Answer will be 1 by 2. It will be 1 by 2. Answer will be 1 by 2. I hope you understood this. Sir, I have not remembered all this. I have remembered only n of E is equal to 12. Yes, you can do it. She visits A before B. Remember n of E is equal to 12. P of E equal to 12 by 24. You write. 1 by 2 also can write. No need to show this much. How you got 12? Not required. You can remember. You can write also. That was, you can write that. You can do that because you are facing. If you are not remember the process number, try to remember the number. Then easily you can do that. No issue that you can do that. You can do that. Total you got this one total. Favorable events is 12 we got. Then 12 by 24 is 1 by 2. Now a die is thrown. What is the probability of event? A multiple of 3. A die is thrown. What is the sample space? Die is thrown 1, 2, 3, 4, 5, 6. All possible outcomes, right? 1, 2, 3, 4, 5, 6. That means n of S. N of S is, we know that n of S is equal to, we have 6. Correct? Now they are taking here. Take the event. What is the probability of event? A multiple of 3. So let it be E is equal to multiple of 3. Multiple of 3 means 3 comma 6. Consider let E be the event multiple of 3. 3 comma 6. So I can write n of E is equal to 2 favorable outcomes. This is implies favorable outcomes only 2. So P of E, n of E by n of S. N of E by n of S. 2 by 6 it comes. N of S. 2 by 6. Answer should be 1 by 3. That will be 1 by 3. Our answer is 1 by 3. Simple one. Next, one card is drawn. So one card is drawn from a well-shuffled deck of 52 cards. If each outcome is equally likely, the probability that card will be a diamond, not an ace. So total number of cards will be 52. So we can consider n of S is equal to 52. I can consider. We have 52 cards. So total points will be 52. The talk if each outcome is equally likely, all probability that card will be diamond. So you take event A, let A is equal to event A. A is equal to, considering because they are telling here a card is drawn. So let A be the event of drawing a card. Drawing a diamond here. A be the event of drawing a diamond. Drawing a diamond card. Drawing a diamond, but you know that in a diamond we have number of diamond cards will be 13. The talking A is drawing a diamond card. Drawing a diamond card. When you are talking diamond card will be 13. 13 will be there, right? That means n of A is equal to 13 we have. So what is the probability of now? That implies P of A. So 13 by total cards will be 52. So answer is 1 by 4. That's all. Because you are taking favorable outcomes 13 by 52. Only one card you have taken. That is the reason 13 by 52. Some people they will write 13C1 by 52 C1 also they will write. 13C1 is 13. 52 C1 is 52. That was you can do that. 1 by 4. So first subquestion we have completed. Second one they are saying not an ace. They're saying a number of A cards will be 4 A cards will be there. 4 A cards. You can think second problem. Consider second problem I can write. We can consider this one. B is equal to, see I am talking about this one. Second problem, B is equal to drawing not an ace card. Drawing a which is not an ace. Drawing a card which is not ace. Drawing a card which is not an ace or non-ace card, right? Drawing a non-ace card. Drawing a non-ace card. You tell me number of non-ace cards will be n of b. Total cards 52 we have. In that ace cards will be only 4. Non-ace cards will be, you can see here, n of b equal to, I can consider total number of cards 52 minus 4 ace cards, it will be 48 non-ace cards. We get non-ace cards will be 48. So probability of drawing a non-ace card, because not an ace, that means probability of B. When I am talking probability of B is equal to, it will be probability of B will be favorable events P of B, N of B, number of points, N of B by N of S, it will be 48 by, I can write this one, 52. Correct. By 13. Is it right? By 30 is your answer, right? Always remember. So this is a problem here. Number of cards 52. Drawing a diamond card will be 13. Favorable events to diamond 13. So P of a 13 by 52, 1 by 4. Now, non-ace card. Card should not be an ace. Drawing a non-ace card. B 52 minus, what is 4 here? Number of ace cards will be 4. Remaining 48. Probability. N of B by N of S, 48 by 52, 12 by 13 your answer. With this I have completed today's session. These are the 1 mark and 2 mark questions. Few more 2 mark questions I am going to explain tomorrow. Tomorrow morning session I am going to take it. I will tell you the timings tomorrow morning time, around between 9 to 10. I am planning to take the class tomorrow. Tomorrow I am going to take the morning session. I will complete the probability topic. Tomorrow I am going to complete probability and sets also. Sets takes around 40 minutes. Probability takes another 20 minutes. Both I will complete tomorrow with 15 minutes gap. 9 to 9:30 probability will be completed. Then after that 10 to 11 I will complete sets. These major topics I think I can expect major topics I am going to complete. I hope you should study from tomorrow onwards, tomorrow afternoon onwards you should study your first exam, board exam I think, right? So to do that almost I am going to complete maximum topic tomorrow morning 9 to 10 I may complete. After that I will upload other topics, statistics and like only statistics and mathematics pending. Those 2 topics I will do before your exams. I will complete that. Any specific topic do you want? Let me discuss in the chat box. I can help you. You can discuss in the chat box. I can help you if you want any specific topic. Thank you everyone. See you tomorrow. Is it fine? Any specific topic do you want? Let me know in the chat box. I can help you. Do you want any specific topic? You can discuss in the chat box. Yeah, Lavanya, yes, I will do the statistics The coming days I will complete statistics also. I will do that. Tomorrow I will complete probability and sets. After that I will do one statistics takes only half an hour. I will complete that. I will complete statistics also. Fine then. See you in the next class. If you like the session, you can like it. Yeah, I will do that. I will do that. Before exam, I will complete statistics. Before exam, I will do that. Yeah. If you like the session, you can like it. Right. Bye then. Yes. Okay then.